Hello, everyone. My name is James, and I will be your host for today's webinar. Welcome to the impact of artificial intelligence on smart factory control networks. Joining us today are two speakers from Moxa. First, we have Paul Wacker, who leads the Technical Services Division at Moxa. He has a deep passion for technology and its impact on the world. With over 25 years of experience in industrial automation and IT, he has extensive expertise in connecting a variety of industrial devices to networks. Also joining us today is Rich Wood, who leads a team of product and industry marketing managers here at Moxa. He has over 25 years of industrial automation experience and deep domain knowledge of networking and control systems used in industries like manufacturing, power, oil and gas, and transportation. All right, so let's go over some housekeeping items before we begin. The webinar is going to be 60 minutes, including some time for questions at the end. If you'd like to submit questions, please use that Q&A function. If you will also see the occasional poll question pop up on your screen, we encourage you to participate in those. The recording will be shared so you can go back and watch the webinar on demand. And at the end, there will be a survey. We appreciate your feedback on the presentation. And with all that in mind, I'll go ahead and pass it off to Paul to kick off our webinar. Paul?
Fantastic. James, hey, thanks so much. And for all of you joining us today, really appreciate your time. I know that's a valuable thing. And I hope that between James, Rich, and myself, we can impart some ideas for you and help you kind of navigate this interesting technology called artificial intelligence. With that, I'm going to take the first couple of sections here as kind of working from the edge of the network up, if you will, talking about some of those connectivity obstacles that some of you have perhaps faced already or facing or soon to face. And from there, I'll pass it off to Rich, where Rich will have a chance to talk a little bit more about some networking technologies and how that relates. All right. So in that first section, I thought as a good starting point, take a look here at, and with many of you, coming to attend today, looking at interesting technology here. This is a survey just at the end of last year, at the end of 2024, conducted by ARC Advisory Group. Perhaps a number of you know about them being kind of the premier analyst firm looking at industrial automation and manufacturing. And they did a global survey of decision makers and those within manufacturers that are looking out towards the next few years into what are kind of some of the key technologies that they're expecting to impact their business and operations. And I thought this was interesting in the realm of today's topic. And particularly if you look, obviously, the first one that's up there that's on everyone's mind is, artificial intelligence and machine learning, right? But if you go a little deeper, I thought it was interesting that there's a lot of uh, interwoven aspects of the first five items that really kind of weave an interesting story there, right? Obviously, cloud infrastructure, edge to cloud integration, those are not always full cloud. A lot of those technologies, in the past we've seen virtualization. Now we've seen containerization, come into on-premise applications. That's a large part of AI. Obviously, that last one, there's a whole specialized segment between AI that kind of talks about industrial analytics with the application of AI technology to that. So the takeaway here is that if you look at this, here's the top five things on a lot of folks within manufacturing their mind of, trying to navigate how's that going to impact my business? How do I leverage those technologies to, accomplish my, business goals and objectives? So I think that kind of helps set the tone for today on that. Um, from there, I wanted just to take a little bit. All of you probably have different levels of understanding of artificial intelligence technologies, and it's a little difficult to unwrap them all. I want to take a few moments just to kind of talk about within that umbrella of AI. There's a lot of very specialized technologies that you'll see referred to today, and probably things that you'll want to do more to look at of, going perhaps a little deeper in these areas. Starting at the left and working to the right, the first one here is machine learning, right? That's where we're utilizing large data sets to have the ability to take that and make inferences from that to be able to kind of come up with abilities to, build a knowledge base. And that's all done without, traditional programming methods, right? That's closely coupled with natural language processing, and this is that text or speech conversation. I would kind of venture to say that a lot of you have probably played with some of the tools, whether it's Copilot, Chat GPT, pick whatever flavor of AI chatbot. With those two kind of coupled together, you see some of the power of those technologies coming together, right? Maybe a little closer to our realm in manufacturing, computer vision. There's the traditional programming aspects of doing computer vision. Now we're seeing some really interesting forays of artificial intelligence, coming in to make that even more impactful with the level of detail and the speed at which things can be done. And there's expert systems which have been extended with machine learning to be able to have specific knowledge bases. And then another one that's probably close to a lot of us is, integration of AI technologies. This you'll see probably more of this in the type of cobots, in types of some of the standalone robotics that are able to do, more advanced types of capabilities on them. So in a nutshell here, under this umbrella of artificial intelligence, a lot of interesting technologies, and with these different building blocks, you can do a lot of different things and interesting things to, achieve the results that you're looking for. So I imagine a lot of you are on your journey to, doing some form of digital transformation, right? Some of you may be really far on the left still, and that's okay. Everybody has a different business and different history and different goals and objectives, different size of organization. And I thought what was interesting here is you can kind of look at some of the steps that most people go through in reaching this transformation, right? And it really comes with being able to get connected over there on the left. And I would imagine that there's a fair number of you that are still working on that or have parts of their operations that have not yet been connected. And hopefully we'll be able to impart some ideas on you today to how to do that and prepare for AI. Then there's the aspect of once you get it connected, what am I seeing? What does this mean? And then how can I take that and make that actionable with those capabilities? I think this is where a lot of us see that common opportunity for AI to help, take that mass of data and turn that into information. But it's okay to be at different places here, and I think it's also helpful to see a little bit of, what the typical journey looks like for most people. However, I think you'll find that, that's not always an easy journey. That's a straight path, and there's some detours, road barriers, different obstacles on your way. And depending where you're at, you'll see different challenges. A couple of the ones I'm going to cover here towards the top of, being able to get real-time data, right? What about those, and this is a little older term, but I think it still applies, the islands of automation, stuff that's there, but really not connected to the level we'd like to be able to do that. And then for those that are pretty well established, particularly, within your control systems, right? They're pretty tightly coupled between what they do, and trying to get information out of those is not always easy without a lot of programming. So we'll talk a little bit about that. And then I'll pass it off after my section to Rich to be able to talk a little bit more about the networking side of things. So let's take a look at, maybe some ways to work around these obstacles. And I think one of the interesting things here is just kind of taking a look at, the kind of the common paradigm that a lot of us had looked at our operations from. The automation pyramid, as some people call it. From the textbook example, it's referred to as the Purdue model. This has gotten a lot of attention in recent years, utilizing this same model for cybersecurity framework for that. And again, the concept here, just to review briefly, is this layered architecture where you have your, field I/O at the very bottom. Field I/O comes into your PLCs, programmable automation controllers, PC-based automation, up to local HMI. There might be some layers of coordination between up to the control room and then to the enterprise, right? The challenge with this is, and it's a great model, but when we start looking at how can I unlock information, at the edge of my network on those devices, I think a lot of you realize that, a lot of these programmable controllers that are installed in control panels on the shop floor are, really focused on that production process, and they're not really optimized for moving data into the enterprise part of your operation or even into the control room in a lot of cases. And to get to that data, you're probably going to have to do a fair amount of programming, to be able to move that data and put it in a format that you want to, right? So I think one of the things to consider here, and there's a lot of options, but this is, I think, one of the fundamental technologies that a lot of people are finding really useful, is this concept of utilizing publish subscribe messaging, right? A little different than most types of industrial protocols, right? Most have some type of a client server relationship where, there's a explicit read or write from the client to do a specific operation. Some of you may have familiarity with this already. Into some of the industrial networks expose this to some level. I think a while back you probably saw DeviceNet, Ethernet IP kind of adopt a similar model for a more constrained purpose in that capacity. And the key concept here is the devices that have information can freely share that. That's called publishing, as you see over on the blue devices on the left. And then there's this free association of devices that want to consume that information. Sometimes this is referred to as producer consumer or publish subscribe. Those devices that want to consume it are the subscribers, and they can say, "Hey, I want to receive, that data, be it in this example, green or orange." One of the great things about this model is it's really on a configuration basis on the individual devices, as opposed to, if that information hub in this case was a PLC, having to rewrite the application code in the PLC to be able to move that data amongst the different devices, or to make, tables of information available for that. So really powerful concept, really useful in this type of application where we're looking at, AI being able to pull specific data into your system for the purposes of making, more useful decisions based upon that real-time information. And again, this is real time, right? This is not something that's a batch process that happens once a day. This is live as it happens. So given that, let's kind of take another look here at, one of the technologies, and there are a couple different ones. The one that's really risen to the levels of really great adoptions, called message queuing telemetry, or MQTT. And the concept here is to kind of take those publish, subscribe, or producer consumer model and leverage that to be able to share this information. And it becomes more of a hub of sharing information, as opposed to breaking free of that paradigm that we had with the Purdue model. So for those of you not familiar with it, and perhaps a few of you already are, MQTT is not something that just happened a few years ago. It's been around for 25 years. And what's interesting is it came out of oil field technology, where they had large geographic areas to cover and bandwidth was scarce. So the whole model for this is really lean, really efficient, really simple, very much uncoupled to make it easy to have different devices and applications connect and share information. And at that center of the model, it employs what's called a broker that's able to do some management behind the scenes and to make that information available to who needs it. This is all built upon standard TCP/IP networking. So you have that, robust ability to guarantee delivery of information in the right order. You also have the flexibility of being able to transport over different types of technologies. So it can be wired, it can be wireless, it can be cellular, it could be satellite, right? We have the ubiquity that comes by using TCP/IP as a transport. And then we also have the ability to secure this not only with built-in capabilities with MQTT, but also abilities to use modern encryption like TLS encryption for that. And then just real quickly, and this is kind of a discovery point for some of you, I've put a few buzzwords on here if you wanted to kind of go a little deeper. I could probably talk a couple hours on this, but for getting through our content today, I'll keep it brief. While MQTT is kind of the means to move raw data, there are extensions to MQTT. One that's real interesting called Sparkplug has a way to standardize the payloads, that is the format of the information, and how you transfer that. So is it an 8-bit value versus a 32-bit value or a float? Versus things also like how do I know where data is and how can I discover it? So it's really great how Sparkplug's kind of been layered on top of MQTT for this. And the last thing is it's an open standard and open source, so it's not controlled by a specific vendor. And as such, it's getting a lot of use not only in manufacturing applications, but in a variety of applications that span technology in a lot of different sectors. All right, and without going too far into that, I thought that was helpful. One other concept that's really important here is the concept of the MQTT topic. So a topic is kind of like a communications channel, and it's simply just ASCII text. It is case sensitive, and it allows you to define a hierarchical view of the data that's representative. So, an example this might be a dairy application. So, at this plant, there's the pasteurizer, and it has a temperature, and that is maintained by the broker, and then this allows you to have devices that are the producers of this information send that data to the broker, and then the broker can distribute that as supported. This is the most simplistic level. It's kind of free form on how you structure this based on your application. And there's some cool things. So, for example, if you want to do monitoring of everything on that piece of equipment, you can replace temp with a wildcard and be able to get all of the data published on that subtopic, if you will. So lots of power here. I wanted just to kind of keep it to basics to give you a sense of, how cool this technology is. So let's go a little further with that. So let's talk about, kind of a key concept. So I've got over on the left a device that wants to share its temperature. And so this device is going to form a connection with the broker, and the devices on the right-hand side. In this case, we've got an HMI and an AI application that want to connect to that. So the key concepts here is the devices that want to have access, they send a request to the broker, say, I want to subscribe to temperature. Once they do that, and you can have multiple devices do this. So in this case, if we want to have also multiple things subscribing to the same data, our AI application can do the same thing. That's a persistent connection, and it's kept open. And then when there's an event that drives an update to temperature, this could be based upon some hysteresis with the temperature perhaps changing by a certain amount, a report by exception, if you will, or it could be time-based or some combination of that. When that temperature is published, then that is sent to all of the devices that subscribe. So you can see it's very loosely coupled, very simple to understand what it does, but it gives you a huge amount of flexibility to be able to make information easily available and not just form one-to-one relationships, but one-to-many relationships for this. And well, I've just shown a one-way transaction here. All of these devices can both publish and subscribe, and you have the ability to control that. So let's talk about, how you might put that into practical usage and understanding that a lot of you probably don't have, MQTT installed. And if you wanted to install it, what are some options for you? Well, the great thing is you've got a lot of capabilities of that, right? Whether it's a PC-based automation, it's easy to add in plugins for MQTT. A lot of the, next generation controls have that availability. But what happens if you don't want to disrupt your existing control system and you just want to layer in some things on top of that and use your network to transport that? Well, here's where the capability is to have, just kind of plug in or drop in connectivity to do that. And what I wanted to kind of expand your understanding here is there's a lot of this that's off the shelf solutions to do this. So if I had, for example, some type of a serial device, this could be, for example, some type of a digital scale, and I wanted to grab a weight, or it could be some sort of a process instrumentation, utilizing RS-232, RS-422, RS-485, for example. You can easily drop in something called a serial device server, which has the ability to take serial data and encapsulate that and then do a little bit of a protocol conversion and then send that via MQTT back to your broker. Certainly one way for, somewhat intelligent devices to capture that. And again, both ways. You can both read and write to those devices. Another option would be maybe a little bit more relevant would be, just general analog and digital I/O. So there might be instrumentation in the control panel. I didn't want to bother changing my PLC program. I could drop this in, overlay this on the existing signals that are there and pick up, digital signals or a 4 to 20 milliamp loop, or it might be other sensors like a 0 to 10 volt, plus or minus 10 volt analog signal. Or you can even have hybrids of these that might have a thermocouple if you're looking for, adding a temperature sensor. So easy to do, drop in remote I/O that can get you on and connected to MQTT. And then sometimes you have equipment that's a little more intelligent and want to have access to that. Another way that's easy to drop this in and start, being able to get that connectivity you're looking for to embrace AI. Another option is a protocol gateway. And for those of you that aren't familiar to these, they're kind of a dedicated specialty appliance that allows you to connect to different protocols. For example, it might be some assets that might talk Modbus, right? And it's ubiquitous. It's just amazing how much stuff is still produced new with Modbus as well as what you might have installed. Or it might be something like, talking Ethernet IP and be able to take that and bring that over to MQTT. So again, whether it's, just simple plain I/O, both analog and digital, whether it's some type of serial technology, or even Ethernet protocols, which we have over there on the right. There are different off-the-shelf capabilities to be able to easily connect these to your network. So how about an application? Let's take a quick look at, maybe what something might look like. Here's one of those applications for a customer that was embarking on this journey, and they had, like perhaps a lot of you, I have an existing PLC. I really don't want to have to, get in and disturb that application. So they chose their route to drop in a gateway to be able to, on one side talk Ethernet IP and then be able to make that data available via MQTT using one of the more popular open source brokers called Mosquito, and then bringing that into an edge compute platform that had AI analytics built in that was able to take that and produce the results they were looking for their factory doing condition-based maintenance. So this is a nice example, and I wanted to use a simple one just to show you folks that, it doesn't have to be complex to be able to test the waters on this. And I imagine a lot of you are embarking on doing a small little lab project or, perhaps a small pilot. How do we understand these technologies and vet them out a little bit for larger scale usage? So with that, I've done a lot of talking here. Let's get a little interaction going, and maybe James, you can help me here. In what AI use cases are you folks most interested in? Love to kind of have you folks share a little bit about, where you're at on your journey and what you're looking at. And from those different options, right? Robotics, predictive maintenance, quality control, machine vision, process optimization, digital twins, generative design, edge analytics, and there's a few more options down there. Make sure to look all the way down to the bottom and find out, which of those technologies are kind of fitting for you. We'll give it another moment or so there. I still see some coming in. Why don't we call it there, James? Let's see what we have for the respondents. All right, interesting. So, as I kind of expected, a lot of folks looking at robotics and autonomous systems. Well, hey, thanks for your feedback on that, and really interesting to see. And we'll try to tailor our content today a little bit as we can for that. And just kind of summarizing there, uh, if I can, just to kind of wrap up that section, and I'll hand it off to Rich here. The key takeaways in that section was hey, even if you're just starting on this journey, it's really easy to get your equipment connected and be able to leverage some interesting new technologies. And I'd really encourage you, if you haven't looked into, publish subscribe messaging and specifically MQTT, it can really make it easy for you to get access to that data. And one thing I've just realized I forgot to mention is one of the great things about this technology, if you've been applying cybersecurity technologies to segment your network, moving traffic through routers is not easy. The way MQTT is architected, it can do outbound connections through routers, going from the edge up without a lot of work. And then again, I tried to share that this is not bleeding edge technology. It's been around and been really vetted over 25 years with a lot of capabilities. With that, let me turn that over to you, Rich, and let me give you the screen back, or let me give you control back, and it's all yours.
All right, thanks, Paul.
My pleasure.
So now that we've talked a little bit about connecting those field devices and that are required to produce the raw data that AI relies on. Now we're going to talk a little bit more about the network itself and how that data is transported and the additional load that the networks have to handle as a result. So we're going to talk a little bit about industrial reliability and how important it is that the network is solid and reliable. We'll talk a little bit about the increased bandwidth that is required with this additional load of data, how the networks scale and become larger and more complex. And then finally, we'll talk a little bit about industrial cybersecurity. So when we talk about reliability, I think one of the things that I found interesting was how much it typically costs to have an hour of downtime in a production environment. So I've seen a bunch of different studies ranging from $50,000 an hour up to over $2 million an hour. But this recent survey looked and said for manufacturing, it typically is around $1.6 million an hour. Obviously, that depends on how much of the network actually goes down. But at the bottom there, you can see, like consumer packaged goods, it's not quite as expensive since you've got a lot of different pieces of equipment that are operating independently down at the bottom. And towards the top of that graph, you've got automotive, which is, a highly staged process type manufacturing where the any one line goes down, it takes down the whole production line. And for this reason, predictive maintenance is one of the top AI applications in manufacturing. But as I mentioned earlier, all of these things require a reliable, available network to transport that data from the source to the AI engines that are utilized. So as far as reliable networks, we'll talk about industrial design, a transition to managed switches, which is pretty common when you start connecting the various elements within a plant. It's pretty common to see a lot of use of unmanaged switches, and those really don't scale well at all. Network redundancy, we'll talk a little bit about architecture and designing your network so that it is as reliable as possible. And then some troubleshooting tools that if there is a problem, how do you find out about it and find it and fix it quickly? So when we talk about industrial design, it's fairly common to see, especially in the early phases of connecting machinery in a factory environment, that there can be just using whatever's lying around to, as far as networking devices. But manufacturing facilities have a lot of kind of unique conditions that don't exist in a typical IT environment. You've got power interference, magnetic fields, and applications like oil and gas. You've got flammable gases, transportation, oil and gas. A lot of the process automation. You see extreme temperatures, humidity, and moisture. Manufacturing environments aren't always the cleanest environments, so you've got airborne particles and contaminants, shock and vibration, and power supplies are one of the things that fails fairly frequently in a production environment. So a typical industrial device is going to be designed with wide temperature ranges in mind. Typically fanless designs, since anything that's got anything mechanical in it is more likely to fail. So the typical fan-cooled devices that you would see in an IT temperature-controlled room, we typically will design fanless design for industrial environments. And then you'll see EMS protection, surge protection. You don't always have the cleanest power in a manufacturing environment. For some of the outdoor applications, conformal coating services. And it's pretty typical to see industry-specific certifications. So if you're in an oil and gas environment, that there would be specific oil and gas certifications. Same thing for transportation, factory environments. And you typically see longer warranties on industrial devices, since in an IT environment, typically you're rotating through your equipment every, it can be as short as 18 months to 3 years is probably typical. Whereas in factory environments, typically things go into service and they don't get replaced until they break. So that could be 5 to 10 years or even more in some cases. So shifting to a discussion of unmanaged versus managed switches. So unmanaged switches are used all the time from the standpoint that they're very simple. They're dumb devices. There's no CPU. There's nothing to configure. So they're great as far as being plug and play. You can take a handful of devices, plug them into an unmanaged switch, and now they're all talking to each other. But there is no redundancy. You can't manage an unmanaged device. So they do have their limits. Whereas a managed switch, now you're introducing a CPU. It's more of an intelligent device. It does have a user interface and needs to be configured, but it gives you monitoring capabilities. These are typically used in larger networks. They do have a lot of features, which I'll talk a little bit more about in the next slide. But the biggest drawbacks of managed devices is they're typically more expensive up front, and they do require configuration and expertise to deploy them properly. So when we start looking at managed switches, you'll see all kinds of specifications and acronyms that talk about the different technologies that are used in a managed switch. But I just want to kind of simplify that for you, that all of those different technologies fall into four main buckets. The first is efficient network performance. So things that help the network manage traffic. So Paul was talking a little bit about the publish subscribe model. In order to do that, you need what's called multicast traffic. An unmanaged switch is just going to broadcast that traffic to the whole network, whether they've subscribed to it or not. So using managed switches allows you to limit the traffic on the network to just the devices that have subscribed to a piece of data. Security. So I mean, obviously we'll talk about security in more depth at the end of this presentation. Easy network management. We'll also talk about that as far as being able to visualize and manage what's going on the network. And then finally, network redundancy. So we talk a little bit about self-healing networks. So typically what we'll see is a factory will typically start with a bunch of equipment. Each piece of equipment probably has its own mini network with a PLC and a handful of devices. But when we talk about islands of automation, this is what we're talking about. And typically at some point, somebody makes the decision to connect them. And typically, a typical IT network topology of, star topology there, where you're just using switches to expand the connectivity. It's simple, but it also creates a single point of failure. So if you lose one of these switches, you lose everything below it. And if you lose that top switch, you lose the whole network. So one of the things that's pretty common in industrial control networks is the concept of redundancy. So a ring topology is more often than not what you're going to see in an industrial environment where you've got multiple paths for the traffic to go. So if you lose a particular link or device, that there's an alternate backup path that can kick in and keep things up and running until you have a chance to fix what's broken. But there are a lot of different technologies available. And we'll talk a little bit about these. On the left, you start with mesh, where you're basically connecting every device to every other device, which is highly reliable and self-healing, but there's a lot of connections you've got to make, and that winds up being too costly when you get to a large network. STP and RSTP are open protocols, or spanning tree or rapid spanning tree. It also self-healing. The original spanning tree took about 15 seconds to kick in. Rapid spanning tree, you've brought that time down to about 1 second. But you still see that, PLCs, when they're looking for an input, typically they'll time out somewhere around 50 milliseconds to 100 milliseconds. And so if it's taking a second for your network to heal, then you're going to start seeing things time out. And then we introduce Turbo Ring. Turbo Chain is Moxa's proprietary redundancy protocol, which brings that recovery time down to 20 milliseconds. So obviously that's below the threshold that the PLCs are typically looking for an input. And so you're basically seeing no timeouts or anything like that because of in the event that there's a network issue. And then finally, for applications like substation automation, where there really is no tolerance for any type of recovery time, you've got dual network or ring topologies that duplicate the traffic so that you get that recovery time down to 0. But those are typically prohibitively expensive for your traditional factory automation type applications. And finally, we'll talk a little bit about troubleshooting. So having some sort of network visibility to allow you to see if you've got a link that's that's getting bogged down, or you have a device that stopped responding. Being able to see that and quickly fix it and get up and running helps improve your network reliability. And finally, alerts and events logs. These can really help you by pinpointing when there's a problem on the network, where it is, and helping you decipher the sequence of events that led to a failure. So with that, we'll kick into another survey question here, which is what is your biggest concern regarding industrial network reliability? So the first option is having sufficient bandwidth, network security, network redundancy, network design, or troubleshooting. So we'll give you guys about 30 seconds or so to input your feedback here, and then we'll share the results. All right, why don't we wrap this up? And so it looks like the number one concern here is network security. No surprise. That's one of the things that has risen to the top because it does have such an impact on reliability. If you get a breach on your network, it can take down the whole network, and that can be catastrophic. All right. We'll move on. So next is network scale and complexity. So the three things I'm going to talk about is IT-OT convergence, or the connecting of IT systems to OT systems, managing thousands of devices. Once you've got all these sensors and other devices connected, now you've got to manage those devices, and finally managing multiple locations. So with IT-OT convergence, really what we're talking about is taking the industrial control network and connecting it to the enterprise network, and sometimes eventually to the cloud. Especially in AI applications, we typically see the servers that are running the AI software are typically in the enterprise network. And so you're feeding data up from the control network into the enterprise. And that introduces some complexity from the standpoint that IT experts have different concerns and different abilities than your typical OT counterparts. One of the things that we typically see is in an OT environment, as Paul alluded to, you've got tons and tons of different protocols that are typically operating. And, in many cases, you've got, proprietary systems running that rely on those protocols. And so there is no real good way to unify them. So a lot of industrial devices will support multiple industrial protocols as far as being able to communicate and be managed in those different protocols. And then finally, using software, you can also start to communicate using more open protocol type data, such as RESTful APIs, web widgets, or OPC or MQTT, to communicate between the IT and OT systems. And finally, since in many cases we're seeing that where IT professionals are helping set up the networks and then the OT people need to maintain them, we support both command line interface, which is the interface that IT professionals tend to use to configure devices, and then graphical user interfaces for the OT folks, since that's typically what they're used to seeing on PLCs SCADA. So giving you a graphical way to see the same information and set up the configurations the way they need to. When you get into managing thousands of devices, just deploying all those devices can be a challenge. So using mass configuration tools that allow you to go in and configure multiple devices at the same time can be a real time saver deploying the network. But also if you've got to do any configuration changes or security changes, being able to do that on a mass level is a big help. So for all of you that were concerned about cybersecurity, one of the things that we see that is probably the most preventable vulnerability in industrial networks is poor password management, if there's any password management at all. So being able to implement policies where you go in and change your passwords on a periodic basis just to keep everything as secure as possible. Those processes can be automated. You can do things like requiring different cases of letters and combinations of letters and numbers and symbols, and then generating randomized passwords for maximum security. Keeping your devices updated as far as firmware, whether that's the latest version of firmware to get the best performance out of the device, or whether that's a security update that fixes a known vulnerability or bug. Being able to see which devices are updated or not updated, and be able to look at the various firmware releases and see if the features that have been added are relevant to your network, and deploy the ones that you deem fit, can be very helpful. Last thing I'm going to talk about is connecting multiple cells. So it's pretty common in the example I had before, where you've got a lot of different pieces of equipment. Now you're connecting them up. Each piece of equipment has its own little network on it. And if most manufacturers tend to use the same IP scheme for each device, that can start to generate IP conflicts on your network. So one of the things that you can do is, and what I'm showing here is basically that within the control panel, the PLC for each control panel has the same IP address. The HMI has the same IP address. But when you put those all on the same network, you're going to get conflicts. So natting is a simple way of being able to connect those devices and translate that into a plant-wide IP schema that doesn't have conflicts. It also has the benefit of segmenting the network to a degree that has some security benefits as well. And then finally, managing multiple locations. So connecting multiple locations, is often necessary with these AI type applications, but not being able to see the networks is a big challenge. And so using tools like network management to be able to, see the network devices at each location, to know that the networks are healthy in the various sites, and be able to manage that all from one location. And just a quick pitch on our MX Studio suite of products, that network management, mass configuration, and deployment tools. This is a real automation-friendly software package that helps you manage those devices. Which brings us to our next poll question. What has been the biggest challenge for you as you look at implementing AI? James, can you launch the poll? .
Yeah, it looks like the poll failed to launch. Let me give that another shot. Okay,
There we go.
we're up.
So connecting edge devices to the network, getting various protocols to work together, network complexity with all of the connections, scaling the network to handle the bandwidth requirements, or managing the network. So we'll give about 20 seconds here to get some of the responses in. Take about 5 more seconds here. And when we look at the results. So it looks like connecting edge devices to the network was the top, followed by getting the various protocols to work and networking complexity. All right. And finally, we'll wrap things up with a little bit about network security. So with cyber attacks on industrial control systems, I think one of the things that this particular survey uncovered was that ransomware attacks against industrial organization increased 87% from 2021 to 2022. And that trend continues. Some of the key engagement findings include that 80% of people had limited OT visibility to their networks. They had undisclosed or uncontrolled external connections, and they had issues with network segmentation. So some of the challenges that we typically see is, from a cybersecurity standpoint, is increasing regulatory pressures. Various governments and agencies are putting requirements in place, especially for infrastructure. We're seeing the blurring of the borders on the network. Going from air gap systems to OT network systems to IT/OT convergence to cloud connectivity and then secure remote access, or in some cases non-secure remote access. And then, as I mentioned, the rising network complexity. From a business perspective, some of the expectations is that we'd be able to detect those security incidents faster, minimize the scope as much as possible if there is a vulnerability, and then get things back up and running quickly. So that, and from a regulatory standpoint, really time-sensitive reporting of incidents that require complete information. So one of the things that went into play recently in Europe is the NIS2 requirements and CRA requirements. But this is basically the EU Union basically said that these are the requirements that must be in place for industrial networks, or they would start to see fines. In the US, we don't see anything that comprehensive, but there are a lot of regulations, depending on mostly industry specific regulations around cybersecurity. We're seeing a flattening of network topologies. Where you're looking at the pyramid that Paul showed before, where there were kind of clear stages of connectivity within the network. We're seeing that flatten out, which simplifies the network, but also makes segmentation of the network much more important to minimize the impact of a breach. And then, as I mentioned, rising network complexity. The large scale networks are more difficult to manage, more difficult to defend. There's still a lot of systems in use that don't have adequate security features built in, whether that's the networking devices themselves or the protocols that are being used. So here are some of the top gaps that need to be closed. Lack of network visibility is a big one. Lack of network segmentation, difficult or impossible devices to patch, such as some of the systems that you've got are like old Windows systems that there's known vulnerabilities, but because of your process depends on those systems that you can't update them. And then insider threats. Really, one of the things that we've seen for years is that the biggest cause of security related breaches is actually unintentional breaches by employees themselves. So that was just kind of a high level overview of some security concerns. We do have an upcoming webinar specifically on OT network security with Felipe Costa and Hans Jen. These are two of our cybersecurity experts that have a lot to share, and we'll go into that in a much more depth than we were able to today, given our time constraints. So in summary, we talked about connectivity challenges, we talked about network reliability, we talked about managing large-scale networks and network security, all of things that are major concerns as you implement AI in your factory setting. And that brings us to our final poll question, pretty simple one. Would you like us to connect you with a Moxa expert to discuss your project?
All right. Thanks, Rich. Thanks, Paul. As Rich mentioned, let us know if you would like us to reach out to you about any questions or any projects that you want to discuss further. We'd be happy to connect with you and help you out there. So next is going to be our Q&A session. It looks like we're coming up on the hour pretty quickly, but if you'd like to stick around to hear some of these questions, you're more than welcome to do that. Let me go through the first one here. The question is, how secure is MQTT?
Hey, thanks, James. Yeah, I noticed that was on the poll, pretty high on the list for networks, right? So important topic. There's actually multiple levels of that. I mentioned a little bit that, from the standpoint of on the wire, there's the ability to use TLS encryption, which is, best in class. That's used for, example, secure desktop via web browser. In addition to that, there are provisions to do authentication. So there's ability to do username password type abilities to limit specific users and devices for that level. So verify what clients are connecting. And then there's also abilities within the broker to implement specific authorizations, which devices can have specific topics or access to those. And that those are kind of the three main provisions for that. So, fairly secure.
Thanks, Paul. Here's another one. You mentioned several redundancy protocols, but did not mention MRP. How does MRP compare to the other protocols you mentioned?
Yeah, that's a great question. So MRP was originally a proprietary protocol that was opened up and made open. So typically with MRP, it's a ring topology. You're going to see between 2 and 500 millisecond response. There are proprietary versions of MRP I think they're called fast MRP, that will get you down into the 10 millisecond range. But yeah, they're very kind of fit in between RSTP and some of the proprietary protocols like TurboRing and TurboChain.
Thanks, Rich. Here's another one. With IT-OT convergence, who typically takes responsibility for the OT network?
Yeah, so we've kind of seen some phases of that, where several years ago there was a pretty strong trend towards the IT team trying to take control of the OT network. But I think in a lot of cases they realized that there's kind of some conflicting objectives there, where the IT teams are more concerned about data security and confidentiality, whereas the OT guys are more concerned with keeping the network up and running. Security is important to the degree that it impacts reliability of the network. So we have seen a shift towards maybe IT helping out deploy the network, but then turning things back over to the OT people to manage the network from day to day. And so for that reason, we are seeing the OT people having much more of a say in as far as what winds up getting deployed, since they have to manage it.
Okay. And I think time for just one more question here. It's another MQTT question. For connecting I/O to MQTT, how is change of state communicated?
Yeah, that's a good question. It goes a little deep, but basically, when you want to be able to send that message to the subscribers, the two key ways that's done is either by seeing a change by a certain percentage, because we don't want to keep sending the same value and tie up all the network resources. So let's say that the tank level increases by 1%, that can be the trigger to send that message. But if the tank level doesn't change and you're worried about being able to have that still sent periodically, you can do that time-based as well, or you can do a combination of those two.
Okay,
Those are the typical mechanisms used by most folks.
awesome. Thank you. And you know what? I will sneak in this last question here. When is the upcoming security webinar? I think this is the one that you spoke to earlier, Rich. I can answer this one. Actually, Rich, can you go back one more slide to the, let's see, there's going to be a QR code. Sorry, maybe one more slide. There you go. If you're interested in attending this webinar, go ahead and scan that QR code with your phone, and you can register for that webinar. It's going to be taking place on May 13th. All right, everybody. Thank you all for joining today's webinar. We'll be sending a follow-up email with a link to the recording so that you can revisit any of these topics that we covered. A survey will also be shown at the end of this session. We appreciate if you could give us your feedback. And lastly, big thank you to Paul and Rich for sharing your expertise on how AI impacts smart factory control networks. This wraps up our webinar. Thank you, everyone, for attending, and have a good day.